Hello students. Hi. So how are you all? Uh, welcome to our maths class. And of course, we are continuing our polynomials and factorization. We completed 3 exercises. So we have 2 more exercises. And before going to the next exercise, that is 2.4, we have to study one important concept, and after that we can go to the next exercise. So very important concept and very useful, even examination point of view and even for higher classes also. So very useful. So before going for that actual concept, now I will explain what is the factor. Factor already we studied even from the 5th class onwards, or maybe in 4th class. 4th, 5th, 6th, 7th, 8th, every time you may be heard this word factor. Suppose say 20 is divided by 4 or 5, for example. 5 4s are 20. Remainder is 0. If 5 is exactly dividing 20, because remainder is 0. If remainder is 0, then we say that it is exactly dividing. Exactly dividing. Exactly dividing. Or we can also call it as 5 is factor of. 5 is exactly dividing 20, we can call like this. Or we can call 5 is a factor of 20. Or we can call it as 20 is multiple of 5. 20 is multiple of 5. All are same meaning. In the previous class also I explained this. So if one number is dividing another number, if the remainder is 0, then the first number is called factor of the second number. If a number is exactly dividing another number, if one number is exactly dividing another number, then that first number is called factor of the second number. That remainder should be 0. Exactly dividing means, what is the meaning of exactly dividing? If you divide, then remainder is 0, means we call it as exactly dividing. So whenever remainder is 0, we call that divisor is a factor of the dividend. If the remainder is 0, then divisor is the factor of dividend. So that is a factor. Now, in polynomials also we have to find the factors. Find the factors of given polynomial. Suppose 20 is given, we can find its factors. So 2 will divide 20, 2 tens are 20, 3 will not divide, exactly divide. 4 will divide, 4 5s are 20, 5 will divide, 5 4s are 20, 10 will divide, 10 2s are 20, and now these are the factors of this. So similarly, of course, 1 is a factor of every number and itself is a factor of 20 is a factor of itself, because 20 1s are 20, 120 is a 20. 1 and that number will be common and remaining you can find. So like this, if a number is given, we can find its factors. So now a polynomial is given, how to find its factors. That is very important. So for that, one theorem is going to help us. One theorem will help us to factorize. That theorem is called factors theorem. The theorem itself is called factors theorem. It is used to factorize the given polynomial. And the interesting thing is, it is the reverse statement of the remainder theorem. Remainder theorem, from that only we get the factors theorem, because remainder theorem is used to find the remainder. So if that remainder is 0, then automatically that first degree polynomial will become the factor of that given polynomial. So like that, it is nothing but the extension of the remainder theorem, which is called factors theorem. So I am writing the statement of the factors theorem, and the statement and definitions we have to use exactly from the textbook. See here. If f of x is a polynomial of degree greater than 1 or equal to 1 and a is any real number, then x minus a is a same is written in converse. Actually, this is a statement, and you write down this complete statement from the textbook. So, the given polynomial is say p of x. So, if the polynomial is divided by x minus a, then remainder will be f of a. If remainder is 0, then automatically it is called a factor. So, both the ways it will be true. So, this is used for finding the factor. See here, a simple proof. What happened here? P of x is divided by x minus a. Then we will get the quotient, we will get the remainder. If f of x is divided by p of x is divided by x minus a, then we will get some quotient. This will be the remainder. This is the general division rule. So we have a relation between all these four. You know that relation. Dividend is equal to divisor into quotient plus remainder. That formula you know, that is called a division algorithm. So here P of x is divided by x minus a. Let quotient be q of x and remainder be r. Then according to division formula, division rule, dividend is equal to divisor into quotient plus remainder. This is the division rule. Dividend P of x is equal to divisor x minus a into quotient q of x plus remainder is r. Write down up to here. But according to remainder theorem, remainder is f of a. We know the remainder theorem. Remainder is f of a. So then this will become P of x is equal to x minus a into q of x plus, in place of rx you can write f of a because remainder is f of a. Now, first case. If P of a is equal to 0, P of a is, that is P of a. So, in all the cases use P only because it is taken as P. If it is taken as F, you can use F. So, if P of a is equal to 0, then what happens? P of x is equal to x minus a into q of x plus this is 0. So P of x is equal to this multiplication of these two. See here 20 is equal to 4 into 5. Then we say that 4 is a factor of 20, 5 is also a factor of 20. Like this, So this multiplication of these two means this is also factor of px and qx is also factor of px. So now hence x minus a is a factor of the given polynomial. This is the proof. So here given polynomial is p of x, say it is divided by x minus u, then let quotient be q of x, remainder be r of rx. Then according to the division rule, the dividend is equal to divisor into quotient plus remainder. Dividend is p of x is equal to x minus a into qx plus r. This is the division rule, holds good for every division. So, but remainder according to the remainder theorem is p of a. So this is p of a. R is nothing but p of a. So if p of a is 0, this will vanish, this will go because it is 0. Then only this much remains. So if p of x is multiple of these two, then x minus a is a factor of p of x. Write down this. Write down all these steps. In the second case also let us take. Second case is if x minus a is a factor of x minus a is a factor of that given polynomial, then p of x is equal to x minus a into q of x plus remainder will be 0 because it is a factor. Factor means remainder is 0. Remainder will be 0. So remainder is equal to 0. X minus a is a factor of p of x means same division formula, p of x is equal to x minus a into qx, because it is a factor, remainder will be 0. I am not writing the remainder. So it is very clear that, say take x is equal to a. P of a is equal to a minus a into q of a. So this is a minus a, 0 into this is 0. So p of a is equal to 0. So therefore, if x minus a is a factor of p of x, then p of a is equal to 0. So this is proved in both the ways, as original statement and converse of it. If p of a is 0, x minus a is a factor. If x minus a is a factor, p of a is equal to 0. Both are proved here. So if x minus a is a factor, then take x is equal to a, so that p of a is equal to 0. So both ways we proved it. So this is the Factor's theorem, and you write down and you practice it. Remainder theorem and Factor's theorem, both the theorems you practice 2-3 times and get a clear idea on it. And let us conclude here with this Factor's theorem. Tomorrow we are going to solve the problems based on this Factor's theorem. Okay students, thank you.